Hey guys, welcome to this new series where we will be building a in-memory key value store like Redis from scratch. We're gonna keep the features of the key value store pretty simple, but what we're gonna be doing is we're gonna be focusing more on the distributed components of it, like leader election, replication, and so on. And we're gonna be seeing how to actually implement those from scratch. So let me first walk you through the plan for the entire series, and then we can start with the first set of features. Alright, so this would be a in-memory key value store database. It would essentially support three, maybe one more: set a key value, get a key value, delete a key value, and ping and pong. Right? Read the other ping, you send ping, it gives a pong, something like that. Right? We will also be implementing a basic TCP server similar to how Redis does, and we'll be seeing how Redis passes the set key value, the protocol that it sets. So we'll be building our own protocol here for set getl. We would be building disaster read. If people have put in keys in your database and the machine restarts for some reason, you should be able to kind of come back to some definite state earlier and not start empty, right? So we're gonna be implementing disaster recovery. We will be implementing synchronous and asynchronous replication. We would be seeing how synchronous replication would work, how asynchronous replication would work. Since we're going to be doing replication, we will also have to do leader election, because what if your leader dies? You will have to select a new leader and your rights have to start going to that leader, right? So we will also be looking at how to do leader election using Raft. So these are the kind of features that we're going to be building out in this entire series. Alright, I have some more documentation here. We have one main.go file which currently has nothing in it. Let me encrypt. So we have a file. Right now we have nothing in there. We have a folder called core. So in the storer.go file, we have a interface called data storer. Alright, this is a generic interface. So this interface defines the functions that any data storage module that we implement has to use. Alright, so that essentially means get, set, and delete in our use case. The K type is the generic type for the key, and V is generic type for the value. What we will be doing is storing the keys as strings and the values as an array of bytes. We've implemented generics here because let's say today you want to do an in-memory key value store. Tomorrow you want to let's say keep disk-based key value store where you can also have maybe integers as keys and whatnot, right? So to keep it extensible, the interface is generic, but right for the time being. So I also have a in-mem-store.go file which defines how the in-memory store works. We have a struct.that in-memory store which has the data set that we're going to be storing. It essentially takes the key as string and the value as byte. We will also be using a mutex because now since it's going to be a database, there are going to be a lot of concurrent reads and writes, so we'll have to be thread safe. So we're using a sync.rw mutex, which is a read-write mutex. You can choose to take on either reads or write, right? So that's what the mutex is. We have a function new in-memory store which creates the in store, right? Essentially just creating the struct. The default value for the mutex, we have not given the mutex here. The default value for mutex is an unlocked mutex, and then it becomes locked. Alright. Now we've implemented the functions set and delete. Let's go through them one by one. Now set is pretty simple. You take a write lock. Defer means once the function has executed its last line, then run this line. Alright, so this essentially says take the lock right now. When the function is completed, unlock, right? So the moment we take the lock, any other concurrent request which wants to do will not be able to set the key in the map. Alright, and now since we've deferred the unlock, now what we do, we take set the key value where in the map, right? Okay, so we have a get function which now takes a read and it again defer the unlock to the end of the function. Now what we're going to do, we're going to try to fetch the key from the data in memory map, and we're going to see if it's not present, we return a key not found error. Otherwise, simple, right? It's pretty much just setting values on a map, except for making sure that it's thread safe. That's it, right? That's how simple and in-memory, just a raw in-memory store is. But we're going to be building so many features around it, which will make it really complex. And again, finally, we're going to have a delete function, which again does a write lock, defers the unlock, and deletes the key from the data if it's present, right? Ideally, we should maybe check if key is present here, maybe return an error or something like that. But I think for the purposes of the tutorial, it works. I've also written a test suite for this, which will help us run tests and benchmarks better, right? Essentially, you do a get after put, it should return the value. So we have a test suite which says set foo bar and get foo, we should have valid values. Similarly, we have some other tests here. You can go through this and in your own time and see what tests can be added. And I would suggest that as homework for you guys for this video. We also have benchmarks for get, set, and delete, which is useful for running benchmarks, seeing if there are any race conditions also on, right? So this is what we have currently. We have the basic implementation of the in-memory storage, the map storage, right? Next, we'll be building a basic TCP server around this in-memory storage. I hope you like this video, and I hope you like this new series that I've started. If you guys like it, please like, share, subscribe. It would really help out the channel, and I'll see you guys in the next video. Bye.